Welcome to all. So, in our specific pedogenic process, today we are going to discuss about podzolization. Podzolization, itself it says that podzol. Podzol means it's a pod means unlike it is a ash-like. We can see it's a ash-like. It is under ash-like. So, what is the definition of this podzolization? Let us see some profile layers here. So, layers of profile, what are those? You can see some organic layer and topsoil will be there, and here it is called. So it's a process of soil formation result in the formation of podzols or podzolic soils. So let us deep dive in deep about this podzolization. It's a process of accumulation of silica and elevation of sesquioxates. So what is happening here? While leaching, what is happening, or during the process of elevation, what is happening? The sesquioxates, the iron oxides, will be removed, and accumulation will be left out here in this portions. Ashy gray horizon with no organic matter will be left out. Only silica will be left out, and sesquioxates will be removed. So it is almost a reverse of your calcification process due to leaching of all bases including calcium. So what is calcification and all? We have discussed in our previous video, link in the description. So let us see in detail. It is the reverse of your calcification process. Now, what are the favorable conditions? So, if I want to say what are the conditions which favors this podzolization in the soil profile? What are those conditions? Very first condition, we need a cool and humid climate is highly required for this type of specific pyrogenic process. And we need a sandy or silicaceous acid parent material, and that too having a poor reserves of weatherable material. And all these conditions, your sandy type of texture, acid parent material, or a poor resource of weatherable minerals, all this favors the operation of podzolization, and this helps in an easy percolation of your water. So all these conditions, if your soil should have a sandy type of texture, acid, if there is acid parent material, and if you have very poor resource of weatherable minerals, and all these conditions will create a favorable condition for your podzolization environment, and followed by acid loving vegetation, and especially in a coniferous type of pines, hemlock, and heath, and all these trees are acid loving. If this vegetation is there, definitely we can see there is a good chances of podzolization process will be taking place in that type of soils. And followed by under calcium free acid environment, that's pH will be in a less than 5. So naturally, if there is a pH is very acidic condition, we can see the fungus play a major role in organic matter decomposition. So under this condition, what is happening? We can see there is a less microbial activity declines the polysaccharide production and keeps the soluble organic products into insoluble form. This is just, it's a continuation. Please take it a note. It's the insoluble form. So microbial activity will be very less, and the polysaccharide production will keeps on down. And all the soluble organic products, what will happen? Which will be converted into insoluble form. And the soluble organic what and after the remaining soluble organic acids, what will happen? React with these SQ oxides which have been leached out, and remaining clay minerals, all those will react. Those or these soluble organic acids will react with these SQ oxides and remaining clay minerals, forming a what? These form some complexes, organous SQ oxides and organic K complex. So this form a complexes. And after when the soluble acids and SQ oxides and all these clay minerals form a complexes, and these complexes are soluble form and be moved off or will be removed by the percolating water to the lower horizons. So this condition, so this complexes during the leaching process, what will happen? All the SQ oxides and remaining clay complexes will form a complex with the soluble organic acids, and those soluble forms will be percolated to the downward layers of your horizon. Let us see somewhat more details. And apart from the above explanation, we can see these aluminium ions. Aluminum ions in this in a solution hydrolyze. That means it hydrolyzes and makes a soil solution very acidic. As we all know that aluminum contribute to the soil acidity. This is the reaction. So aluminum hydrolyzes. That means it form a aluminum hydroxide, and it releases H plus ions. This contribute to the soil acidity. And what happened as this materials moves out? What happened due to this heavy intense leaching? Those layers, those podzolic layers, will be appear as in a E horizon appear as a bleach. In a bleach appears. That means you can see the gray color appearance will be there below the surface. And the elevated materials, whatever the materials are deposited or removed from the E horizon, that's due to the elevation, are deposited in the B horizon, has a dark colored BH, BH layer. This is considered as a precipitated humus, and reddish brown layer, that is a BS layer, that is deposition of the sesquio oxides, and yellowish brown silicate layers, which are gradually merged with parent materials. So what happened, what I'm going to explain means, in the previous slide, we can see that soluble form of organic acids form a complex with the sesquio oxides and remain clay complex. So after forming, these complexes are becoming very soluble, and those soluble compounds are elevated, and those elevated materials are deposited on the B horizon, and that B horizon imparted taken the form of dark color appearance and reddish brown color appearance and yellowish brown appearance will be there. And how it looks, let us see some images here. This is what you see. To the bleaching, due to the intense leaching of this layer, due to the sorry so so due to the intense leaching, this one, you see this one, it's becoming gray appearance we can see here, especially in this layer. This is called the podzolic layer. And this BH, you see here, precipitated humus, whatever the humus is there, it was, you can see that the dark color is because of your because of the intense appear this humus humus accumulation will be there. And this reddish color is because of your deposition of sesquio oxides, and this yellowish color you can see is because of your silicate clay appearance. So these are the different images you can see, and followed by hence the matured podzoles. And due to this podzol or this podzolic because it will have a well developed horizonation, we can see if there is a good podzolization is there, means we can see in this type of layer, this type of well matured horizons or layers we can see in our soil profile. Then, thank you. Say no to processed food. Thank you very much.